So what I'm going to go through right now would be the steps of drawing an energy cycle and how we apply Hess's law. Many students have difficulties drawing energy cycles because they do not know the steps of doing it. And so if we follow the steps of drawing an energy cycle, you will find that drawing an energy cycle is actually a very easy thing to do. Take for example, if we have this reaction where we have 2 moles of gaseous carbon reacting with 5 moles of gaseous hydrogen turning into CH3, CH2, the ethyl radical, and this is an unknown enthalpy change that we are trying to find, given the following enthalpy changes that you see in the slide. The first thing to do is to begin by writing out all the equations that are according to the definitions. Enthalpy change of formation, enthalpy change of atomization. So as long as we write out all the equations with all these enthalpy changes, that will be the first step. Now many students would think that, oh, I do not have the time to write out all these equations and they want to go straight into drawing the energy cycle. But that is actually a no-no. I will explain why it is necessary to write out all the equations. Because after we write out all the equations, the next thing that we're going to do, this would be step 2, we will want to choose the equation that has got the most details to start our energy cycle with. So there are 2 possibilities here. We can either start with the equation that represents the enthalpy change of formation of ethane, or we could use the equation that represents the bond energy of the first CH bond. Those 2 equations would have all the details that we need in order to continue the cycle. Many students will make a mistake here and they will begin with the equation that has the unknown, which is the delta H1 equation, 2 moles of carbon plus 5 moles of hydrogen, giving us our ethyl radical. And this would be a mistake because beginning with this equation that has the unknown enthalpy change, you will find that there are only 5 moles of hydrogen atoms. There is 1 missing mole of H atoms that will be very difficult to account for later on. So after we have all our equations, let's recap. We're next going to choose the equation that has got the most details, either the enthalpy change of formation or the bond energy equation. And I'm going to illustrate by using the enthalpy change of formation. So beginning with this equation, we are now going to see how to insert the other equations into this energy cycle. All we need to do is to look for common species that are exactly the same. The number of moles will need to be accounted for. For example, the next equation we're going to use is to change the solid carbon atom into gaseous carbon atom. And we will need to multiply that equation by 2. And then we would have used the enthalpy change of atomization. The next thing to do is very important. We will need to balance our equations along the way. So step 4, we need to copy the 3 moles of H2 gas that we did not change. And again, at this stage, many students would like to make multiple changes at the same time. I do not advise doing so because when you make multiple changes, the tendency of making careless mistake will greatly increase. So we're going to continue and repeat steps 3 and 4. The next equation we're going to see is how we can change the H2 gas to H atom, and it will be 3 moles H2 gas to 6 moles of H atom. So the positive 218 kilojoules per mole, we will need to multiply by 6. If we have written out all our equations, it will be obvious that we need to multiply the 218 by 6. Here, many students will again make the careless mistake of multiplying by 3. That is, if they forget to write out all the equations, and it would seem to be obvious because there are only 3 moles of H2 gas. But our reference equation involves half a mole of H2 gas giving us 1 mole of H atoms. That's why this value will need to be multiplied by 6. And we repeat steps 3 and 4, meaning we have to balance our carbon. And then we will see which other equation to use next. And it will be changing the ethane now, breaking 1 mole of the CH bond to the ethyl radical plus the H atom. And finally, you will find that the equation that is the unknown enthalpy change would fit nicely to join up the whole energy cycle. And remember I mentioned earlier that if we have started with the unknown enthalpy change equation, there is one missing hydrogen atom. But if we have started with the other equations, that missing hydrogen atom is actually accounted for. And this is where we find the final equation joining and closing up the entire energy cycle. After we complete the energy cycle, it is now time to apply Hess's law. And it is very simple to apply Hess's law. All we need to do is to sum up all the anti-clockwise arrows and equate that to the sum of clockwise arrows, and you will then be able to work out the unknown enthalpy change. Delta H1 in this case would simply be minus 2392 kilojoules per mole. And so this is the method and the steps to follow to draw an energy cycle easily.